Let's continue to part one of investigating trig ratios for angles between 90 degrees and 360 degrees. Consider an angle theta in center position with the point 1 and rad 3 on the terminal arm. Let's recall that our terminal arm is located between point P and our origin. So first of all, we need to show that the value of theta is 60 degrees. In order to do that, we're going to need to use our inverse tan function on our calculators, but before we do that, let's set up what this ratio is actually going to look like. So I have my x value equal to 1. I know that because I know that the point P is at 1 and rad 3. So, of course, I also know that my y value is equal to rad 3, which is indicated at the beginning of the question right here. So I know that my tan ratio is going to be equal to y over x, and since I'm looking for theta, I'm going to have to set it up in my calculator like this: tan theta over y x. So tan theta is going to be equal to, in our calculator, second function tangent, and so I'll do that so you can see it. In my second function, and then tangent button, I'm going to go rad 3 divided by 1, and I will get an answer of 60. And so the first part of our question is done. We need to prove that is equal to 60 degrees. Now what we need to do is we need to calculate the value of r. Unfortunately, I kind of went down to my area here, so I'm just going to square this off, and I'll do it, the second part of this question, b over here. Alright, so this is question b. I need to calculate the value of r. We're going to do so by using our Pythagorean theorem. R squared is equal to x squared plus y squared. I'm looking for my r value. I know that my x value is equal to 1, and my y value is equal to rad 3. And so r squared is going to be equal to 1 squared plus 3 squared, rad 3 squared, sorry. Remember, if we have a radical times a radical and we have the exact same radicand on the inside, that is just going to be equal to 1 plus 3. Therefore, our r value is equal to 4. And so now I can fill in, complete the following using x is equal to 1, y is equal to rad 3, and r is equal to 4. Oh, and sorry, I made a mistake. That was r squared, and so r squared is equal to 4. Therefore, r is equal to the square root of 4. R is equal to 2. Now, for the last part of the question, we need to fill in our trig ratios. Y over r is going to be rad 3 over 2. For our sine ratio, our cosine ratio is going to be x over r, or 1 over 2. And finally, our tan ratio, y over x, or root 3 over 1. If we simplify that, we can forget about that 1, and we'll just be left with rad 3. Okay, so part 2 and 3 are very similar to part 1. All that's happening is that we're told that the rotation angle in part 1, which was this angle here, is reflected in the y-axis. And so if we compare this triangle and this triangle, we'll notice that they're the same triangles. The only difference is they're being reflected across this y-axis. Okay, and so part A, the point Q, x, y, will then have coordinates for Q equal to -1 and rad 3. I know it's going to be a -1 because if it was +1, in the first example, and it's being reflected across the y-axis. So if in the first example it was positive 1 for my x value will now be negative 1. And since my y-axis, my y values won't change at all across the y-axis, I'm going to still have a y value of rad 3. And since the reference angle is 60 degrees, which was our initial angle, if we make a complete flip, I'm going to have the exact same angle starting from my standard position at my origin, and I'm going to end right here. So it's going to be 60 plus 60. It's going to be 120 degrees. Now for C, we need to find the trig ratios. So again, y and r, I know that my r value is also going to stay the same. So my r value is going to be, again, positive 2. I'll be left with rad 3 over 2. My cosine ratio will be negative 1 over 2. Remember, negative 1 was corresponding to my x value. That was reflected. And then my tan ratio will be rad 3 over negative 1. Okay, and for part 3, it is almost exactly the same. The rotation angle in part 1 is reflected in both the x-axis and the y-axis. If this is the case, then we know that I'm going to have two negatives for my initial values of 1 and rad 3. So now I'll be working with negative 1 and negative rad 3. If we go an additional 60 degrees from our reference angle and the angle corresponding from that in part 2, then we will now have a total rotation angle of 240 degrees. And so we need to do the exact same thing. We need to list our trig ratios for sine 240, for cosine 240, and tan 240. And so these are going to be the exact same. We're going to have negative rad 3 over 2, which is my value of r. Let me just put all of these in here so we don't get confused. Negative 1 for my x value, negative rad 3 for my y value, and 2 for my r value. Okay, so for cosine 240, it was going to be negative 1 over 2, and for my tangent ratio, I'm going to have negative rad 3 over negative 1, which a negative divided by a negative will leave me with rad 3. Part 4 is exactly the same as parts 1, 2, and 3. The only difference being that now the rotation angle in part 1 is reflected in the x-axis. And so we're going to end with our terminal arm in quad 4 here. So the point S, xy, has coordinates of 1, since 1 was our initial x value, and since our initial y value was rad 3 up top here, it's now going to be negative rad 3, just like it was in the previous example. And I should have the negative sign outside of my radical sign. It's just a little mistake. So the reference angle is 60 degrees from the beginning, and the rotation angle now, since we moved 60 from here, another 60 degrees was 120, another 60 degrees was 240, and another 60 degrees is going to be 300 degrees from our reference angle. Now we need to list our trig ratios again, which is going to be negative 3 over 2. Now again, I'm using my rules of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, but rather I'm filling in my x, my y's, and my r's. Okay, so my cosine of 300 degrees is going to be 1 over 2, because cosine is equal to adjacent over hypotenuse. So that was going to be 1 over 2. And I'm going to end with my tangent, which is opposite over adjacent, or negative 3 rad 3 over 1. And I'm just going to simplify this into negative rad 3. Now, you can confirm these trig ratios on your calculator. And again, just type these into your calculator and see what you get. Remember to use your inverse trig functions for this part. For this next question, I need to examine all of my trig ratios that we just looked at for parts 1, 2, 3, and 4. For all of these quadrants, or all of these trig ratios I was able to determine using my values of x, y, and r, I need to determine where they were positive and where they were negative. So that being said, I need to determine where they were positive and negative in specific quadrants. And so I'm going to look at quadrant 1 to begin with. So if we look at the triangle in quadrant 1, right here, and we look at all of our trig ratios, all of our trig ratios ended with a positive ratio. And so, since they all ended with a positive ratio, a positive over a positive, I'm going to say that they were all positive in our quadrant 1. Now let's move to quadrant 2 and examine what happened there. So in quadrant 2, I had my sine ratio, which was positive, but I ended with a negative cosine ratio at negative 1 over 2, and a negative tangent ratio of rad 3 divided by negative 1, or negative rad 3. And so that tells me that my sine ratio was a positive divided by a positive, or a positive. However, my cosine ratio was a negative over a positive, which would end with a negative value. And my tangent ratio was a positive divided by a negative, which would also end with a negative value. And so for all of these questions, we need to look at what happened. Where were they positive and where were they negatives? So let's look what happened in quadrant 3. And so I have point P of x and y, or sorry, point R of x and y in quadrant 3 in this question. I'm going to end with a negative and a negative, a negative, and a negative, which tells me, oh sorry, my last one was a positive, not a negative. So that tells me that almost all of my trig ratios for quadrant 3 were negative. And so that was a negative divided by a positive, which ended with a negative. Another negative divided by a positive, which ended with a negative. And then a negative divided by a negative, which will end with a positive. So let's look at our last example, which was in quadrant 4. And instead of going back up, I'm just going to tell you that we had a negative value divided by a positive value divided by another positive value, and a negative value divided by a positive value. So that's going to leave us with a negative, a positive, and a negative. Now, using the same information that we just found at the end of part 4, and determining the sign of the trig ratios, I'm going to use that information to answer this question. So we determined that sine ratios have a positive value in 2 different quadrants. Those were quadrants 1 and 2. The cosines had positive values in quadrants 1 and 4. The tangent ratios have positive values in quadrants 1 and 3. The sine ratios have negative values in quadrants 3 and 4. The cosine ratios have negative values in quadrants 2 and 3, and the tangent ratios have negative values in quadrants 2 and 4. So you're going to have to memorize where all of these values are positive and negative. Now, I know it sounds daunting at first if you look at all of that and all the information we just discovered, but there's this easy way to remember this. It's called the CAST rule, or remembering the mnemonic, add sugar to coffee. So the way this works is that if we add sugar to coffee, so add sugar to coffee, that tells us that in the add in quadrant 1, all ratios are going to be positive. So our sine ratios, our cosine ratios, and our tangent ratios are all going to be positive in my quad 1. Sugar for S for sine, is going to be only the sine ratio is positive. 2 for tangent, T for T, only the tangent ratio is positive, and cosine and coffee, C for C, only the cosine ratio is positive in quadrant 4. Another way you can reverse is just the reverse, C-A-S-T, or CAST. And so there's two mnemonics you can remember, the CAST, starting from quad 4 going up to quad 1, or starting from quad 1 to quad, ending in quad 4 with the add sugar to coffee mnemonic, which I find easier just because it goes from 1, 2, 3, and 4. With this last example, we need to determine without using technology whether the given trig ratios are positive or negative. Now, this is easy to do. All we need to think about is where all these angles are relative to our origin. Where our origin is right here, 0, 0. And if these are standard angles, then they're going to start at the origin, go about the terminal arm, and go around my origin in a clockwise or counterclockwise direction. And so let's begin with thinking about what we know about these triangles. We know that if we have an angle 0, we're going to have a full rotation, an angle of 360 degrees if it rotates a full rotation around. I know this is 90 degrees, I know that this is 180 degrees, and I know that this is 270 degrees. So with all this information, we need to think about where all of these are going to be. So 340 is going to be in quad 4. And so if I know that sine 340 degrees is going to be in quad 4, I know that only cosine, if I use my mnemonic add sugar to coffee, I know that sine ratios are only positive in quadrants 1 and 2. And so that will lead me to infer that if I have an angle of 340 degrees here, I'll name that point P, that my sine ratio is going to be negative. I'm going to do the same thing for all these other angles. For a tangent 227 degrees, I know that 227 is going to fall in here. If I know that I add sugar to coffee, if my angle for tan 227 is around here, then I know that that's going to be, I'm going to call this Q. I know that that will be a positive. For sine 88, I know that this angle is going to be in quadrant 1. I'm going to call that angle R. And if that is my angle, it's in my first quadrant, and I add sugar to coffee. If I add sugar to coffee, then that add means all ratios are positive, which means I again have a positive ratio. For the cosine of 235, where is that going to be? 235 is going to be around here. Let's call that S. I add sugar to coffee. In quadrant 3, only the tangent ratio is positive, so that means the cosine ratio must be negative. Again, I have a cosine of 308. Well, not again, it's the first time. But that angle will be around here. I'll call that angle T. Cosine of 308 in quadrant 4, if I'm adding sugar to coffee, coffee is in quadrant 4, which means cosine ratio is positive in quadrant 4. Then finally, tan 123. 123 is going to be around here, and let's call that U. I'm going to add sugar to coffee in quadrant 2. Only my sine ratio is positive, which means my tan ratio must be negative. For this last example, we need to rewrite the same trig function of an acute angle. So there's two rules in doing this. The first rule is that if we draw what our angle of sine 140 looks like, I know that if this is 0, this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees, that sine 140 is going to fall over here. Now there's two rules. The first rule is to determine whether this ratio of sine 140 is going to be positive or negative. And then we're going to write the positive or negative version of this sign. And so since we know that add sugar to coffee, if we have a sine ratio in quadrant 2, we're going to have a positive ratio. The second rule in determining the functions of an acute angle is we need to determine what the reference angle is. And so if I know that my angle is going to be 140 degrees, then my reference angle is going to be made right here. And so my acute angle then is going to be sine 40 degrees, 40 degrees being my reference, and it's going to be positive because it is in quadrant 2. Now this would be a good time to pause the video. Sorry, the video must have stopped recording, but if you just want to look at the questions that I was filling out while I thought I was recording but it stopped, then feel free to do so now. But I'll continue with examples D to F. So I have sine 287 degrees and I'm looking for the function, the trig function of an acute angle. And so I'm going to start the same way I did last time, with drawing out my x and y axis and finding where sine 287 degrees would be. Since I know that down here would be 270 degrees if I'm starting from my origin of 0 and going around, 287 degrees would be about down here. And so that angle would go in that direction. And the reference angle, if I go 287 minus 270, or sorry, 360 minus 287, I'm going to have a reference angle equal to 73 degrees. And so I know that only if I add sugar to coffee, only cosine ratios are positive in the fourth quadrant, which means my sine ratio would be negative, and my reference angle, since 73 degrees, will be negative sine 73 degrees. Now, the second last one, cosine 308 degrees. Alright, so cosine 308 degrees. I'm going to be around here somewhere. I'm going to go in this direction. This is my reference angle right here. And so again, I'm going to go 360 minus 308 degrees for my reference angle. I will have a reference angle of 52 degrees. And so since I add sugar to coffee, my cosine ratio is in the fourth quadrant, which means that cosine ratios are positive because I add sugar to coffee. I'm going to have a positive ratio, cosine ratio of cosine 52 degrees. And last example, tan 199 degrees. Hopefully you can understand how to do these now. If I have 199 degrees, 180 degrees would be right here, and so just short past is going to be 199. My reference angle I can use right here. 199 minus 180 degrees. I'm going to be left with a reference angle of 19 degrees. So I add sugar to coffee. Again, positive. Tangent 19 degrees is equal to my acute angle. So the last thing that this worksheet tells you to do is just to recognize the patterns in trig ratios. So we have the following pattern of results relating the trig ratios of rotation angles to the trig ratios of reference angles. And so this is something that you can read on your own time, and again, if you have any questions on this, just feel free to ask me in class tomorrow.